So question 16 here, what we're looking to do is use this graph to convert £5 into dollars. So the way we do that is we go from 5 upwards to where the graph hits, and then we go across from there, and that would then read 8. So our first answer, which would be 16A, would be, and this is in dollars, sorry, is the number of dollars, which would be 8. Part B, Lucy's going to convert US, she's going to US on holiday. She converts £500 into dollars. How much does she get? Well, £500 then. What we can do is pick out a value that makes it easy for us. So personally what I would do here is I'd go up at 10. I'm just going to draw straight across the work, but going at 10 tells us that we've got then $16. So if I know I've got that fact that £10 is equal to $16, I can times it by 10, and that tells me then that £10 gives me $160. And if I times that then by 5, that's then £500. You can put that in a calculator if you want, or you can work it out directly. It's $800. 16C tells us that we have a conversion rate. That £1 is exactly $1.75 dollars. So convert $150 back into it. So that's saying every one of them we get £1. So if we work out how many of them go into 150, we'll then get the solution we're after. Now the answer on your calculator comes out as this sort of long monstrosity. Now you know, but it's quality of written communication, that pounds, when you round them, round to pence. So it's £85.71. Question 17. It is a matter of using your calculator well. So on most modern calculators now, you press the square root sign first, type the number in, and press equals, and your answer is 18.3. Now part B, you've got a bracket. Now here's personally what I do here. Now I just play safe. You can use brackets on calculators, but I much prefer to go it manually first. So I work out that 7.2 take away 5.3 is 1.9. And then I times by, work out my other bracket, which is 4.4. And I put that in a calculator. I just find that safer. You generally get a bit less mistakes on that. Part C, it's a half times by 3.64. I think that's a divide. And divide by, just have a look again. Yeah, that looks like a divide. So the first thing I'd advise is that you work out what the bracket is. So we're then saying a half times 1.3. Now when you times something by a half, in effect you actually just half the number. So you could times by a half if you wanted. But your answer then is 0.65. So now we've got question 18. This could take me just a while to quickly sketch out. So what we have here then is already pre-drawn in values. So what the question is saying is shade 3 squares so that the shape has a rotational symmetry of order 2. Well, the important bit about this is that this point here is where we're rotated by. Now it should be more symmetrical, this side's a bit bigger here than it should be. And we're going to make it order of rotational 2. So what we've then got to try and do is make sure the two sides are the same, and then two sort of quadrants, if you like, are the same, and two aren't. Well, if we compare the opposite quadrants here, then to make this the same, just change the colour. So if I'm shading here, these two would then be the same as we rotate around. And if I also rotate here, that point would need to be the same. Now that is order of rotation 2. Why? Is it, or is it not? Well, if I take it, I'll just undo that, sorry. So if I just use this as an example, but I'm going to make it slightly smaller and show you what I mean. So I'm going to copy the exact same shape over here. Now order of rotation 2 means that as you rotate it round on its axes, so if I rotate this round here as a full turn, how many times it goes back into itself. Now you might think here that's been the same because we've still got the same parts up there as we have down here. This one has moved down to there. So actually, if we leave it as it is at the moment, you'll only find it's got order of rotation 1, which can be referred to as no order of rotation. So what we have to do is add in this bottom corner here. So that when we turn it around, that will fit into that halfway through, and then it's a perfect order of rotation 2. Question 19. So we've got parallel spelt out. What's the probability that the letter has an L on it if it's picked at random? Well, we've got 3 then that are parallel with an L out of 8 possible letters. And that's 19A done. 19B, write down the probability that it does not have a letter P on it. So does not is how many options is not P. We've got 1, 2, 3, 4, 5, 6, 7. 7 options where it's not P out of 8 possibilities. Question 20 is a graph drawing one. Right, so what we've done is we've got the graph drawn there, and we're told that the graph is y equals 2x minus 1. Now, what I think of this is a number machine. So we start with x, and the first thing we do to x is times it by 2. Then we take away 1, and that gives us y. So 2 lots of x, and then take away 1. So if I put that into here, and use my x is 2, then it's 2 times 2, which is 4, and then take away 1, 3. Do it for 0. 0 lots of 2 is 0, take away 1, minus 1. I'll test it with this one as well, 3. 3 times 2 is 6, take away 1, 5. So we've now got coordinates, so I'll plot those coordinates on there. So it'll be minus 2, 5. We've then got minus 1, 3. Then got 0, minus 1, 1, 1. We've got 2, 3. And then we've got 3, 5. Now I'll just remove this here. So we've got 2, 3, and then 3, 5. And then we construct a straight line straight through these values, and then label the line y equals 2x minus 1.